Welcome to the FIPy tutorial video on running FIPy scripts. In this video, we will give an introduction on how FIPy scripts work, show you how to configure a FIPy script run, and how to inspect its results. For this tutorial, your FIPy environment must be set up. If it hasn't been set up yet, we refer you to the tutorial video on getting started with FIPy. Step 1. The sections of a FIPy script. We start by selecting a script to run. We will start with the demo feature simple script. First, let's examine this script. The parameters of the script are defined near the top. These parameters will appear on the run page. They allow us to control each script run without having to make changes to the script each time. Below that, we find the execute script function. This is the main function of a FIPy script. The function consists of two parts. First, it performs an initial setup. This includes initializing the parameters and the database if one is used, and connecting to any hardware devices that may be involved. Then, the script starts its main loop. This loop iterates over the different combinations of parameters defined during script configuration. How this loop works exactly will be covered later in this video. Here, the script defines what results it will produce. This particular script simply reports its input parameters as results, along with a color based on a random number. The monitor function called sends these results to the table on the dashboard page. Step 2. Configuring a FIPy script. To run a FIPy script, we find it in the browser and click its Run button. Here, we see all parameters that were defined in the script. Let us go over them in more detail. The attempts parameter is a counter that counts up to a maximum value. It starts with a value of 1 and increases by 1 every time it's updated. Its maximum value is set using this input field. Most scripts have an attempts parameter because in fault injection, producing useful faults is never consistent. Rather, an attack needs to be repeated many times in order to increase the likelihood of obtaining useful results. The laser color parameter is a selection parameter. This type of parameter can only be set to one of its available options. The selected value remains constant during the script run. This parameter is purely here as an example. This script does not use a laser device. Timing A, timing B, and timing C are all integer parameters. These parameters can be set to different modes, which influence how their values change during a script run. Timing A is set to range mode. In range mode, the value of the parameter starts from a start value, increasing by a step size every time it's updated, until it reaches or exceeds an end value. After that, it starts again from the start value. The first field sets the start value. The second field sets the end value. And the third field sets the step size. Timing B is set to random mode. In random mode, the value of the parameter is randomly taken from a uniform distribution every time it receives a new value. The first field sets the lower bound of that distribution, and the second one sets the upper bound. The final field sets the parameter's repetition factor, which dictates the number of times it's updated while the values of parameters above it remain constant. We will see what this means exactly during the script run. Timing C is set to fixed mode. In fixed mode, the parameter is constant during the entire script run, with its value set to that of the input field. Timing D is a float parameter. This type of parameter works the same as integer parameters do, except that its values don't have to be whole numbers. The device IP parameter is a string parameter, which allows any string as input value. This value remains constant during the script run. This parameter is purely here as an example. This script does not use a device accessed by IP. A script run continues until all combinations of values for the parameter configuration have been tried, or until a user stops the run. The maximum number of results that a script will produce is the product of the number of values tried for each parameter. For example, if we set the number of attempts to 1,000, the total number of results this script run will produce is 10,000. This is because there are 5 values timing A can have 12, 14, 16, 18, and 20, and timing D has a repetition factor of 2 times. 1,000 attempts times 5 times 2 results in a total of 10,000 results. To save your parameter configuration, click Save Parameters. FIPy also automatically saves the parameter configuration of a script at the start of a run. Once your configuration is saved, you can leave the run page without losing your changes. When you return to this page with the Run button in the top bar, it will open the most recently saved configuration of the most recently opened script. Now that all parameters have been configured, we can run the script. Step 3. Running a FIPy script. In the table of results, we can see how a FIPy script iterates over its parameters. 4 parameters change between iterations: attempts, timing A, timing B, and timing D. Timing D changes most frequently because it is lowest in the parameter list. It changes twice while the other parameters remain the same because its repetition factor is 2. Every 2 results, timing A changes, going from 12 to 20 in steps of 2. Timing B changes every time timing A does, because its repetition factor is 1. The topmost parameter, attempt, increases by 1 every time timing A has reached 20 and starts back at 12. Let's visualize this behavior. These are the parameters of our script. Range parameters iterate over a set number of values, so those are listed in order. For random parameters, a number of randomizer function calls are listed equal to the parameter's repetition factor. When the parameter loop starts, each parameter is set to its leftmost value. On each subsequent iteration, the bottom parameter steps 1 value to the right. If it's already on its rightmost value, it starts from its leftmost value again, and causes the parameter above it to step to the right instead. This process propagates upwards until all parameters have reached their rightmost value, at which point the script is finished. While a script is running, it is possible to change its parameters. If you do this, FIPy will iterate over the new set of parameters from the start. This means that the attempt parameter starts at 1 again. The ID, however, keeps counting up, as it counts the total number of iterations since the script was started. Step 4. Visualizing result data with FI Spotlight. During an actual attack, each iteration of a script would correspond with 1 fault injection attempt. The result of that attempt would be included in the status window and would be briefly visible in the results table. But how do we get more insight into those results? For that, we can use FI Spotlight. FI Spotlight is a standalone risk cure program that is packaged with and can be accessed from FIPy. It is a tool for visualizing databases with result data produced by FIPy or Inspector. To demonstrate how to use FI Spotlight, we need to run a script that writes its results to a database. For this, we can use the demo feature database script. This script sets up a database, and during the parameter loop writes its results to that database. For this run, we leave the script in its default configuration. To simulate some simple fault injection results, this script generates a random value every iteration. If it's under a lower threshold, the result is colored yellow. If it's over an upper threshold, it's colored green, and if it's between both thresholds, it's colored red. To open FI Spotlight with the data of this run, go to History, and click the button in the database column for that run. This is FI Spotlight. It provides a wide range of data visualization options. This video does not cover all of those options, but rather aims to show off some useful features. Here in the Plot tab, we can visualize the data of our run. For example, if we plot the dice variable against ID, we can confirm that the color is dependent on the dice value. The following two figures demonstrate this. This one plots the colors of results based on their ID and dice value, and this one plots how often a result with a certain dice value received a certain color. Other types of plots are also available from this drop-down, but we will not cover those here. FIPy creates one database per script and one table in that database per run. If you want to look at the results of a different script in this project, you can select the database of that script. Likewise, if you want to look at the results of a different run, you can select the table of that run. FI Spotlight also allows you to filter the data using an SQL query. This is the Statistics tab, where you can get more detailed statistical information about the results. It shows the following information: the minimum, maximum, and number of unique values for each parameter, how often each color was produced, the parameter ranges in which each color was found. Note how this list finds the values of our thresholds, the values that selected parameters have during all attempts, and the result color those attempts produced. And finally, a complete table with all result data. For additional information on the features of FI Spotlight, see the Help tab. This concludes the tutorial video on running FIPy scripts. In this video, we covered how to configure scripts, how those configurations influence the script run, and how you can evaluate the results of a run. For more information on writing scripts or using other features of FIPy, please check the other video tutorials or consult the FIPy documentation. Thank you for watching.